This is a shocker. For a scientist who launched an exploratory craft 45 years ago, it must be extremely rewarding to still be observing it explore regions that were never intended to be explored and half a century beyond its expected life, while also being aware that it is several billion miles away from its launch pad, and sending data back to Earth using technology that is more archaic than even the most basic phone in use today. NASA launched 2 spacecraft on a unique exploration expedition into orbit in 1977 to investigate the furthest reaches of our solar system. And it's been revealed that after 45 years in space, Voyager has uncovered a frightening discovery that has captivated the interest of the entire globe and sent shockwaves across the scientific community. What exactly is this horrifying brand new finding from the last frontier? And what does it portend for all of us back home? Let's find out. 2 of the most amazing spacecraft ever launched would never have taken flight if the stars hadn't lined up. In 1965, the age of space exploration had just begun. Flandreau was tasked with figuring out the most effective way to launch a space probe to Jupiter, or perhaps even out to Saturn, Uranus or Neptune, while he was a part-time employee at NASA's Jet Propulsion Laboratory in Pasadena, California. He plotted the orbital paths of those massive planets using a pencil, a favored precision instrument of the 20th century engineers, and made an amazing discovery. In the late 1970s and early 1980s, all 4 would be strung together like pearls on a necklace in a long arc with Earth. As a result of this coincidence, a spacecraft may gain speed from the gravitational pull of each large planet it passed, as if being pulled along by an invisible rope that suddenly broke, sending the probe flying on its course. Flandreau projected that the journey duration between Earth and Neptune would decrease from 30 years to 12 years as a result of the frequent gravity aids. One drawback though, the alignment only takes place once every 176 years. As it turned out, NASA created 2 spacecraft to make the most of that once-in-a-lifetime chance. Within 15 days of one another, Voyager 1 and Voyager 2, which were identical in every way, were launched in the summer of 1977. They have been operating for more than 45 years and continue to beam information back to Earth daily from the solar system's farthest known worlds. They have lasted longer than any other spacecraft in history and have traveled further. Overall, not a bad record given that the Voyager missions were initially only intended to last 4 years. The Voyager spacecraft surprised scientists when they provided the first up-close views of the moons of Jupiter and Saturn early in their journeys, 4 decades ago. Astronomers had assumed that these worlds would be as inert and crater-pocked as our own moon, but they actually contained active volcanoes and fissured ice fields. Voyager 2 was the first spacecraft to pass by Uranus in 1986, and 3 years later it flew by Neptune. It is the only spacecraft to have traveled in this way so far. They are currently surprising physicists with a number of unexpected discoveries about that unexplored region as pioneering interstellar probes more than 12 billion miles from Earth. The Mariner 10 probe received a gravity assist from Venus on its way to Mercury, making the Voyagers the first spacecraft to use one to reach another planet. Yet the Voyagers would make numerous attempts at helping, with error margins measured in tens of minutes. Their first trip, Jupiter, was around 10 times further away from Earth than Mercury. During the route, the Voyagers would also have to pass through the asteroid belt. The question of whether or not spacecraft could pass through the asteroid belt without being torn to shreds had generated much discussion prior to Voyager. The belt turned out to be essentially empty space, but in the early 1970s, Pioneer 10 and 11 sailed through it unharmed, opening the way for Voyager. The Voyagers, which were approximately the size of a vintage Volkswagen Beetle, needed some onboard intelligence to manage all of these difficulties. As a result, NASA's engineers gave the computers on board the vehicles 69 kilobytes of memory, less than 100,000th the amount of memory found in a regular smartphone. The smartphone comparison is perhaps a little off. The key fob that opens your automobile door has more memory than the Voyager computers. 8-track tape recorders are used to store all the data that the spaceship instruments gather before being broadcast to Earth by a 23-watt transmitter, which has about the same power as a refrigerator light bulb. Both Voyagers are equipped with 12 feet wide dish antennas for sending and receiving messages in order to make up for the feeble transmitter. A one-way radio communication traveling at the speed of light takes about 22 hours to reach Voyager 1 and just over 18 hours to catch up with Voyager 2, because both Voyagers are now so far away from Earth. They advance by 3 to 4 light seconds every day. The Voyager's signals are getting fainter and fainter as they move farther away from us in space and time. The Earth is really noisy. Everything produces noise: radios, televisions, cell phones, etc. So it becomes increasingly difficult to hear these minute squeaks from the spaceship. Even though they are faint, those whispers have altered what astronomers anticipated the Voyagers would discover as they moved into the interstellar portion of their journey. The Oort cloud, a far-off collection of comet-like entities held together by the gravity of the Sun, may extend halfway to the nearest star. It will take at least another 300 years for the Voyagers to arrive at its near edge. Yet interstellar space is far more accessible. Where the solar wind phenomena end is where it starts. The heliopause is a border between our solar system and interstellar space, and estimates of its distance before the Voyager missions fluctuated significantly. Under the assumption that the spacecraft will reach the heliopause at roughly 50 AU, the mission's funding was increased. Yet the spacecraft departed from that landmark without discovering any of the predicted indications of interstellar transit. Scientists had anticipated that the Voyagers would notice an abrupt increase in galactic cosmic rays, high-energy particles shot out like shrapnel from supernovae and other deep space cataclysms at nearly the speed of light. Most low-energy cosmic rays are deflected before they can enter the inner solar system by the enormous magnetic cocoon that the heliosphere creates. It protects us from at least 75% of the outside world's dangers. The Voyager ground team was also watching for a change in the dominant magnetic field to be detected by the spacecraft. The magnetic field of the interstellar medium, which is expected to be produced by nearby stars and enormous clouds of ionized gases, is likely to be oriented differently from the magnetic field of the heliosphere. The Voyagers, meanwhile, had not noticed any such alteration. When Voyager 1 finally crossed the heliopause on August 25, 2012, it returned some puzzling data. Voyager 1 had actually discovered the anticipated increase in plasma density, but there had been no indication of a shift in the ambient magnetic field's direction. Shouldn't that change have been apparent if the vehicle had traveled from a place where the magnetic field originated from the Sun to one where it came from other stars? That surprised everyone. In November 2018, Voyager 2 arrived at the interstellar seashore but did not notice any magnetic field changes. As the spacecraft reached the heliopause at 120 AU from Earth, the same distance reached by its twin 6 years earlier, it added another riddle. All theoretical models predicted that the heliosphere should ebb and flow in time with the Sun's 11-year cycle, but this did not fit any of them. The solar wind ebbs and flows at that time. When Voyager 2 arrived, the solar wind was at its strongest, and if the predictions were accurate, the heliopause should have been further out than 120 AU. As a result of the heliosphere's influence on the interstellar medium, the Voyager's data reveals numerous small-scale changes near the heliopause, but negligible field variation at vast scales. It is anticipated that the spacecraft will eventually leave those turbulent shores behind and come into contact with the pure interstellar magnetic field. Or perhaps the image is wholly inaccurate. The Voyagers may still remain inside the heliosphere, according to some academics. The huge increase in galactic cosmic rays and plasma density that the Voyagers detected, however, has persuaded the majority of experts on the subject. One of the most fundamental concerns regarding the heliosphere could be resolved by an interstellar probe. It's comparable to attempting to comprehend what a goldfish dish looks like from their perspective. The bowl must be visible from the outside for us to understand it. Nonetheless, certain terms such as answering machines, VCRs, and pennies outlive their usefulness. The Voyagers, however, used technology from 50 years ago to transcend their own. These instruments have very little to no software. To operate the spaceship, the Voyagers' designers could not rely on tens of thousands of lines of code. There are currently 5 operational instruments aboard Voyager 2 and 4 on Voyager 1. They are all propelled by a mechanism that transforms heat from plutonium's radioactive disintegration into electricity. Yet NASA has been forced into triage mode as a result of the power output diminishing by roughly 4 watts annually. The heater for the cosmic ray detector, which was essential in determining the heliopool's transit, was shut off by the mission's engineers 3 years ago. Everyone thought the instrument would fail. The instrument continued to function even when the temperature plummeted by about 60 or 70 degrees Celsius, considerably outside any tested functioning limits. It was amazing. The magnetometer and the plasma science instrument will likely be the final 2 Voyager pieces of equipment to shut down. They are kept inside the spacecraft's main body, where they are warmed by heat produced by the computers. The additional instruments are mounted on a fiberglass boom that is 43 feet long. What is the potential lifespan of the Voyagers? If everything goes perfectly, scientists might be able to extend the missions until the year 2030. Just the power makes a difference. It represents the limit. Although the Voyager's journeys will go on even when they are entirely hushed, Voyager 1 will pass Proxima Centauri, our closest neighbour star, in 16,700 years. Voyager 2 will follow 3,600 years later. After that, they will spend millions of years orbiting the galaxy. Long after our sun has disintegrated and the heliosphere has vanished, they will still be there, largely undamaged, unlike our pale blue dot. They might be able to deliver a final message at some point throughout their journey. It won't be broadcast over the radio, and if it is, it won't be by humans. 2 recordings, another form of antiquated technology, are used to convey the message. But not your typical plastic version. They are made of copper with a gold finish and are covered in an aluminium casing. Images and noises intended to provide a feeling of the world the Voyagers came from are encoded in the grooves of the golden discs as they are known. There are 90 minutes of music, including Bach's Brandenburg Concerto No. 2 and Chuck Berry's Johnny B. Good, as well as images of kids, dolphins, dancers and sunsets, as well as the sounds of crickets, rain, and a mother caressing her child. Jimmy Carter, who was President of the United States at the time the Voyagers were launched, also left a message. It reads, "We cast this message into the cosmos. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination and our goodwill in a vast and awesome universe." Beautiful, isn't it? Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.